What really gets me going is that this is not a fraction. This is a notation. Yet after stating this, calculus teachers go on to use it like a fraction. Of course, I'm guilty of this too. This is one of the main techniques. All we have to do is rearrange this equation, put all the y's on one side, all the x's on the other, as if this dy over dx was a fraction of two variables. What we're really trying to say is that if we integrate a function of y dy, that should be the same as integrating that function of y times dy over dx dx. If we can prove this, then those dx's cancel out in the way that we want. If I integrate a derivative, they sort of cancel each other out like squaring a square root. So we have this statement. And the only thing to do now to get what we want is integrate both sides with respect to x. You might notice that the f of y, dy over dx, when integrated with respect to x, is the situation we're trying to simplify. The other side is a little bit clunky, but simplifies rather nicely. And although it's a little convoluted, it's actually a really similar thing happening here. We're basically integrating, with respect to x, the derivative with respect to x, and those should cancel each other out. Basically, we're just ending up with the integral of f of y dy equaling what we want. There are some other issues though. What happens if we start taking these differentials and sticking them in other places? Kind of like in this expression. We'll have to deal with this in a different way, but the answer is very interesting, I promise you that. I'll see you in that one. But that's really just restating our original problem. We can't just cancel out these dx's because they're not fractions. What we're really trying to say is that if we integrate a function of y dy, that should be the same as integrating that function of y times dy over dx dx. If we can prove this, then those dx's cancel out in the way that we want. So how do we prove this? Well, let's take that integral of f of y dy, which is very well defined.